We saw that changes in momentum are brought on by a force acting on an object for a period of time, delta t. What if a force is applied to an object for an extended period of time, acting on the object as it moves through a displacement, delta x? This is another way to quantify the influence of force, but rather than giving us a change in momentum, we say that the force does work on the object, where the units of work are Newton meters. When we calculate the work done by a force, we have to be a little bit careful. Suppose you rearrange your furniture. You apply a horizontal force to move your couch in a horizontal direction. Intuitively, you know that your efforts are contributing to the motion of the couch. Similarly, if you ask your friend to help and they apply a second force, you would expect a greater response in the motion of the couch. However, what if your friend applies that same force but in a different direction? Clearly, direction matters here. When we calculate the work done by a force, we account for the direction of the force relative to the displacement by using the vector dot product. The multiplication of the magnitudes is tempered by the cosine of the angle between the two vectors. Check for yourself that you get a reasonable sense for the amount of work done by your friend in these situations. When multiple forces act on an object as it moves, each force can do work on the object. The total work done would be the sum of the work done by each force, or if you're in a hurry, you can simply look at the net force acting on the object and calculate the work done by this vector sum. It'll give you the same result. Now that we've identified this new quantity work, we need to relate it to the corresponding motion of the object. However, before we can do that, we'll need to introduce the concept of energy.